Alright guys, for this particular problem, it's similar to one of your homework questions, but it's a definite integral instead of the indefinite integral. So part of this is, okay, now what? The other part of the challenge is this one introduces trig functions within it. And I think it's going to be valuable for us to see how do we apply the trig function work. Now just from a get-go, an overview of the problem, I see in that denominator that 1 plus the sine squared of x. I'm really tempted to say, that looks awful familiar to me. And if I look in the back cover of your book, you've got your trig identity stuff back there. It's almost a Pythagorean identity. The Pythagorean identity would have been 1 minus the sine squared of x instead of 1 plus the sine squared of x.
We factor out negative.
But we factor out of both of them, then this will become negative 1 minus the sine squared of x. So still, almost, just not quite. It is good that we can recognize those, but we do have to be really careful with saying, oh, this is what this thing is. What I observe after I kind of jump over the Pythagorean identity into trig identity is now I look at this denominator, and I know that 1's a perfect square, and I know that the sine squared is a perfect square, and there's a plus between them. So go back to the front of my book, or look at my integration forms. That really gets close to being an arctangent result from integration. Because the arctangent uses an a squared plus a u squared. Okay, do we agree with that? Do you see a little bit about where I'm headed with this thing? Okay, I have to identify this form. So over here to the side, I'm going to say I'm going to let a equal the square root of 1, which is still 1. But let u equal the square root of the sine squared of x, which is sine of x. So then I take the derivative of this. I need to know the appropriate du. And what's the derivative of the sine of x? Positive or negative? Good. So I need all of that to be my du. Does it exist in the problem?
Yes.
Wow, that's kind of nice. So I would rewrite this thing to help myself out and saying from an a to a b, once I change to u values, I need to change my interval here because they're different. All of this right here is du. This is a squared. This is u squared. Well, hey, I've got that pattern now, right? So that means the answer to this problem is going to be good. The arctangent of, what's the u?
Sine x.
And then the a is the 1, so we don't have to write in. In this case, we don't have to because it's a definite integral. So we're going to come back in here and we're going between 0 and pi over 2. So that's really one of the other changes we get. Now let's see what we remember about our trig unit circle. I want to take the arctangent of the sine of pi over 2 minus the arctangent of the sine of 0. Oops, excuse me one second. So what's the order we do this in? There's my guess at it. And this was even, so it's got to be right. Anybody else guess that? Your calculator guess that? Okay. Alright, let's do this. What is the sine of pi over 2? So I want the arctangent of 1 now. And then what's the sine of 0?
0.
Do we agree with those things? Remember, we're working inside out, so the sine of each of those angles first. And then I ask myself, what is the radian angle between negative pi over 2 and positive pi over 2 that has a tangent value of positive 1? Well, that's pi over 4. And then the second question I ask myself is, what is the angle that has a tangent value of 0 radians? Or sorry, not 0, just 0. What's the radian angle? That's 0. So I end up with pi over 4 minus 0, which is just pi over 4. So I'm expecting an angle answer to this problem. Questions about that? Okay. Does that help clarify this one just a little bit? Yes, it takes time, and yes, you have to pick out the right formula.